So we're going to start looking at some probability today. What is probability? The likelihood of something happening. So if I have a 6-sided die, see, I've got a really big one right here. See if I can get these out of the package. What's the probability that when I roll this die, I get a 6? 1 out of 6. True for any of them on here, right?
Yes.
What would it be out of if I roll 2 die? How many options do I have here? How many options here? 6. We multiplied the number of possibilities together, so it would be out of 36. So out of 36. So the probability that I roll a sum of 2 by rolling 2 die. A sum of 2. What would I have to get on both of these die if I get a sum of 2? 1. I'd have to roll a 1 on each of these. I'd have to get snake eyes. So that'd be 1 out of 36. Does that mean if I roll this die 6 times, I'm guaranteed to get a 6 on one of them? No, we have our theoretical probability, and then we have what we actually see happen. We're going to look at these two things today. You're going to need some type of device. Your phone would be fine. But you're going to keep track of free throw shots and whether or not we make this free throw or not. So if you go to our Canvas page for today, there's a link right here. So you go to modules, find today's date, or from the home page you can just click on that big blue button that says click here for today's lesson. When you click on this link right here, it should take you to a page that looks like this. And the first thing we're going to do is we're just going to shoot 1 time. So I don't want it to take 10 shots, I just want it to take 1 shot. Has everybody gotten here? All right, so we're going to take 1 shot. So right here I can see, did I hit or did I miss? Miss. I missed on mine. So I'm going to record mine as a miss. If yours was recorded as a hit, then you want to record it as a hit. So I'm going to use X's for misses and checks for making it. So proportion of makes. I've got 0% so far because I missed it. Oh. There it goes. You're welcome.
Thank you.
Happy Monday. So I got 0 out of 1 or 0%. All right. I'm going to shoot again. I'm just going to take 1 more shot again. What do I got now? Yeah, I made that shot. So I made this shot, so now I've got 1 out of 2. I'm sitting at 50%. You need to record it on yours, what you got when you shot. I want you to go ahead, take this up to 5 shots. Did you make or did you miss? I'm going to fill it in on mine as well. It is recording all along the way. It's keeping track of all of your shots here. Ooh, I've made 3 out of 4 so far. Look at me go. Yours should look different than mine unless you've managed to have the exact same number of hits versus misses. I'm doing good. I am now at 80%. If you notice on your paper, it jumps from 5 to what? 5 to 10. So we're going to take a lot of shots. So right here where it says shots, and we were just taking 1 at a time, I'm going to bump it up to what? I'm going to bump it up to 5. It shows me all of those. So I've made 7 out of 10, so I'm sitting at 70% now. I want you guys to finish filling in your table. So you're going to go by 5s for 10 and 15 and 20, and then you're going to go by 10s. If there's anybody that needs help or that's confused about what we're doing, please let me know. We're going to go up to 80 shots total. One more for me. So looking at your results, what do you think the true proportion is. It's like mine started, I got 0, then 50, 67, 75, 80, 70, 53. It's kind of all over the place. As I got more shots, what was happening to those percentages? Was it still all over the place? No, it started to kind of narrow down, right? And while it didn't stay constant, it did start hovering around the same number. If you were to guess, based on, we'll look at my results right now, and then I'll have you look at yours. Looking at what happens over here, what would you guess the true proportion to be? 67, 68, maybe 69?
Yeah.
Based on what happened at the end, I think I'm going to guess 69, 70% as I got more and more shots there. So I'm going to make a guess here that I think this is about 69%. I want you to answer on yours based on what you saw happen at the end. Look at your percentages at the end and make your best guess about what you think the true free throw percentage is. And then I'm going to go back to that app. It's got this little checkbox here that says show true probability.
That's the...
See if it can show you the true probability. Yours was really high. Nice. I want to kind of sketch what it shows here. Doesn't have to be a super precise sketch, but I'm going to sketch what it's showing. All right, so I'm going to come over here and put my sketch in. And here, this green line on here is the true free throw percentage that it showed me. When you look at this graph, one of the things that I notice about it is that it's fairly unpredictable for this first little bit. And towards the back, where it evens out, it's starting to become more predictable back here. What do you think we could do to make our prediction even more accurate? When did we start to see it kind of even out and become more predictable?
At the end.
At the end. What was happening at the end?
Took more shots.
We were taking more shots. So taking more and more and more and more and more shots, we're going to get a percentage that is more and more and more consistent, more predictable. So take more free throws. This idea right here, where when we repeat these trials over and over and over and over and over, and we see more predictability there, that is called the law of large numbers. Law of large numbers. And this kind of hits on that same idea that you guys were telling me about the beginning. when I held up this dice and I said, what's the probability that I roll a 6 when I roll this? And you all told me what? 1 out of 6. Does that mean if I roll the dice 6 times, I'm guaranteed to get a 6 exactly once? No, but if I roll the dice over and over and over and over and I record every trial, the more times I roll that dice, eventually we're going to see that percentage get closer and closer and closer to 1/6. That is my law of large numbers. When we repeat this and repeat this and repeat this, we get closer and closer and closer to the theoretical probability. I want you to write down what your percentage was here. So wherever your line was, mine was at 80%. You want to write down where yours was. So what my percentage tells me is that if Mrs. G takes many, many, many free throws, about 80% of them will be makes. Or she will make the shot. That would be my interpretation of the probability. If she does this over and over and over and over and over and over and over, approximately 80% of them she will make. Go ahead and flip it over on the back. Probability is a long-run relative frequency. Our probability is always going to be in between 0 and 1. We can't ever have anything less than 0%. We can't ever have anything over 100%. In the short term, my probability is unpredictable. We saw that with our free throws. We made one, we missed one, made one, missed one. Short-term probability is rather unpredictable, but our long-term probability, the more times we repeat this, it becomes predictable. And the law of large numbers tells me that if I repeat something over and over and over and over, I do it many, 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 many times, the proportion of my desired outcomes is going to approach the probability. After you get this recorded down, I want you to take about 5 minutes to answer the 3 questions down at the check your understanding portion.
Would this make you a better gambler?
Could it? Yes. However, don't count cards. The discipline of studying probability and of coming up with these ideas did originate from people trying to become better gamblers. However, its applications now extend far beyond that particular aspect of it. when you get down to the questions at the bottom, when it's asking for the probability, it gives you 6 probabilities here to choose from. You're going to choose 4 of those down below, but it gives you the numbers to be choosing from there. Absolutely, you may. Go ahead and take the bathroom pads. That little fold up square, yeah. It's been folded and refolded and folded a gazillion times. About 3 more minutes, and then we're going to go through those 3 questions at the bottom. Again, for question number 1, they give you 6 probabilities to choose from, 6 numbers to choose from. You're going to choose 4 of these to answer the questions down below, and then try to come up with an example. So I want you to try to come up with an example of something that is impossible. Try to come up with an example of something that is certain. Try to come up with an example that is very unlikely, but could happen. For number 2, if you're not quite sure how to interpret it, look at the interpretation that we gave on the other side of the page, how we answered that very last question, and try to model your interpretation off of what we did on the front side. Which one of these 6 numbers would represent an absolutely impossible event? It could never occur. 0. So my example that I gave was rolling a 7 on a 6-sided die. Can't happen. If I roll one die one time, and it's a standard 6-sided die, I can't ever roll a 7. Or if you were drawing cards from a deck, what's the chance that somebody holds out just a regular deck of cards, no tricks, and you draw a card that says 13? Yeah, absolutely impossible. What about a certain event? It will occur on every trial. 1. That's the same as 100%. So the example that I use for that is if I roll a die, just a normal 6-sided die, I've got to roll either a 1, 2, 3, 4, 5, or 6. Those, like one of those things is guaranteed to happen. Or if somebody holds out a deck of cards to me and they said, pick a card, any card, again, no tricks, just a normal standard deck of cards, I'm either going to draw a red card or a black card. Those are the only possibilities. It's 100% guaranteed. Which one of these would be unlikely, but it would occur once in a while in a long sequence of trials? 0.001. Very unlikely to occur, but not impossible. So the example that I have is guessing a correct number from 1 to 1,000. It's unlikely that you'll guess the right number, but it is possible. Which one of those numbers shows an outcome that will occur more often than not, but it doesn't occur almost every time? 0.6. So if I've got a spinner, looks like this, landing on green, I've got 3 of those 5 sections that are colored in green. Chances are I'm going to land on green when I spin that. It's not guaranteed, but it's highly likely. How would you interpret an 11.1% probability of spinning bankrupt? Yes, sir.
I said this outcome is unlikely, but will occur once in a while.
Will occur once in a while. Anybody else have another interpretation of this? If you spin that spinner over and over and over and over and over, what's the chance that you land on a bankrupt? 11.1%. So after many, 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 many spins, about 11.1% of those spins would have landed on bankrupt. So yes, not a guaranteed. It's not an unheard of outcome. Does that mean if I spin the spinner one time, I'm going to get a bankrupt? Could I get a bankrupt?
Yeah.
What about if I spin that spinner 8 times and I don't land on a bankrupt in any of those 8 spins and I go to spin it again?
You can get bankrupt.
Am I guaranteed to get a bankrupt?
No.
What's the chance that I get a bankrupt on that 9th spin?
11
Still 11.1%. And that is question number 3. The next contestant worries they've had 8 spins that have not been a bankrupt. They're worried that their chance of getting a bankrupt is higher. Nope, it's still just 11.1%. It does not matter what spin came before. Short-term probability is very unpredictable. We want to look at long-term trends. Down here in number 3, I've seen this idea come up a lot recently as we've seen some differences or changes in climate patterns. And we've talked about like, oh my goodness, this is a 100-year flood. That does not mean that if we have a 100-year flood happen this year that we're safe for the next 99 years. It means that out of a 100-year time period, the chance of a flood that bad is 1 out of 100. What we're seeing is that some of these probabilities, as our climate is changing, some of these things that only statistically happen once in 100 years are occurring more frequently. Short-term probability is very unpredictable. before we go over your test, I do want to talk about one thing very quickly because not everybody is familiar with it. Playing cards. Because there is a question on the homework. This gets brought up a lot of times in probabilities. It's a standard probability type of question. So I want to talk about the breakdown of playing cards real quick. How many cards are there in a standard deck? 52. How many colors? 2 colors. How many black cards? 26 black. And what's the other color? Red. 26 red. How many suits? 4. The black suits are going to be spades and clubs. There's my really bad club. And my spade. Sorry, guys. My allergies kicked up really bad over break. Red cards. Hearts and diamonds. How many of each? 13. We've got 1 through 10 that are number cards. Jack. Sorry, not 1 through 10, 2 through 10. My bad. Jack, King, Queen. And an ace. So 2 through 10 that are numbers, Jack, King, Queen, and ace in each of those suits. So you'd want to use that for any questions about playing cards. So far, so good? Cool.